or we compare two products, which is better? How do you decide? Okay, so you have learned this approach in a different way in statistics. So now we'll use the uncertainty approach. So compare sample mean with the standard, variance estimated from the sample. So the variability, the variance is estimated from the sample itself. For example, so this is something which you do in your project, final year project. So you make a new material perhaps. So the tensile strength of a standard steel is 8 MPa minimum. This is the standard steel. And now we have developed, a batch of project students have developed a new steel. So is this new steel better? How do you know? So first you have to test. You take a random sample of 10 specimens of the new steel, and when tested it gave the results. X bar equal to 12.8 MPa, standard deviation is 6.43 MPa. Is the new steel better? So based on average alone, new steel is better. But we know that we should not consider only average. We have to consider the measurement uncertainty also. So what is the probability that it will be lower than 8? Is there a probability? Yes, you have to consider this. 6.43 is the standard deviation from 10 specimens. So what will be the uncertainty for the range uncertainty for the tensile strength? So X bar is 12.8, standard deviation is 6.43. So standard deviation of X bar will be root 10. Sigma of X bar is S by root 10. So that is the standard uncertainty of X bar. Then from 10 readings, the degrees of freedom will be 9. Accordingly, the T factor will be 2.26. So the expanded uncertainty will be 2.26 into 2.033 will be 4.599. Therefore, confidence interval will be X bar plus or minus capital U, that is 8.2 to 17.399. So now this is the coverage interval with 95% confidence. So now the standard value is 8 and your confidence interval varies from 8.2 to 17.4. How much? 8.2 to 17.4. So this is clearly above 8. So we can say that the new steel appears to be better. Okay. Okay, this is clear. So here we are considered only the repeated readings, the uncertainty in the repeated readings, that is the standard deviation. But if you consider other sources of uncertainty, for example, suppose there is an uncertainty in the tensile testing machine itself. It is calibrated, the uncertainty in the calibration is plus or minus 1.5 MPa. So assuming it is to be uniformly distributed, the standard uncertainty of the calibration will be 0.866. So the combined standard uncertainty will be root of this calibration uncertainty plus the repeated readings, uncertainty to the repeated readings, root sum of squares. So now the combined standard uncertainty is 2.21. So since this calibration uncertainty is with infinite degrees of freedom, we can determine the effective degrees of freedom. Therefore, T95 with, so rounding down 12 degrees of freedom, the T factor is 2.17. So expanded uncertainty is 4.815. So coverage interval is 7.98 to 17.61. So now the coverage interval goes to below the standard. So now we cannot say that it is above the specification, clearly above. there is an uncertainty. We cannot say that the new state is definitely better if you consider the other source of uncertainty other than repeated readings. So this is something which statisticians don't take into account. They don't talk to you about the uncertainty of the UTM. They simply say that do take only a type A uncertainty account in your hypothesis testing you would have learned in the other sources of uncertainty. So that is why, so in metrology, we consider other sources of uncertainty also. We determine the combined standard uncertainty. And if you consider that, then we can't say that the new material is definitely better. There's a possibility it may be better, but we can't be very sure. With 95% confidence, we can't say. Okay? This is clear? Okay, so limitation. So now, even now, we have considered only uncertainty of UTM. What about uncertainty of environment? Uncertainty of measuring in the diameter of the tensile test specimen. So many other uncertainties also have to be taken into account. So that is why we have already learned that all sources of uncertainty should be considered. Then only you'll get the correct picture. So of course, you should be able to judge. So in real world, that is why it is very difficult. In theory, in courses, we'll tell you what are the sources of uncertainty. But in the real world, you have to judge for yourself what are the sources of uncertainty. So that is why when using phyphox, try to determine what are the sources of uncertainty and then try to analyze.